Well, what did we just see? We saw when a paper can fly, it is because of the air resistance. But when we crumple this paper into a ball and fly it against a paper, which is a spreadsheet of the same weight, we see that the ball falls down first. Now, why is that? That is because of the surface area. Since the weight is the same, here the density has increased since the surface area has decreased, because of which it experiences lesser air resistance. Therefore, air resistance requires surface area, weight, and density to oppose the gravity pull. That means these three objects can determine how much air resistance an object experiences and how slow or fast an object can fall down. Hi, today I'm going to talk about a parachute. Well, a parachute is a piece of paper, plastic, or a cloth which, when spreads out, experiences air resistance and slows down the movement of an object. Well, what is air resistance? Air resistance is that force applied by the air which slows down an object. It is basically that force which acts upon it when the air fills inside the parachute slows down. Well, this is used in parachutes, and parachutes require the air resistance to work. Parachute is a piece of cloth which is attached to the threads, and these threads are then suspended on an object which is slowed down when thrown from a greater height. Here is my popgun parachute. So, what happens? There are two pistons attached to the syringes. These syringes are connected by this tube. As soon as I press this piston, the smaller piston goes flying out and falls down with the help of this parachute. Well, here is my popgun parachute. So I have two pistons in the syringes which are connected by this tube. This smaller piston has a parachute attached to it. So what happens is when I push this piston, the bigger piston, a lot of air pressure is generated over here. This air pressure is what pushes out this piston, the smaller piston. When a lot of air pressure is generated and it goes out flying, and with this parachute, it comes down slowly. Let's see how it works. Well, let's try with the bigger parachute. So, what is the difference with the bigger parachute? Bigger parachute has a bigger surface area. That means it can gather more air under it and therefore experience a larger air resistance. Well, is surface area the only thing that matters? Let's see. I'm going to use this doll, this pin, this car, and see what happens. Well, when I used this doll, it took approximately 2.5 seconds for the parachute to come down. When I used this pin, it took 4 seconds. For this car, it took 1.5 seconds only. For this ball, it took 3 seconds approximately. What's the difference? Well, all the things over here weigh differently. That means heavier the object, the lesser time it will take for the parachute to come down. That means the weight of the object determines how much air resistance can be bared by the parachute. Well, let's try what happens when we attach this balloon to the parachute. As you just noticed, the balloon went flying and it carried away the parachute with it. Well, but when we leave a balloon, inflated balloon in the air, it goes here and there. But it did happen this way in play. Why was that? Well, as we discussed, parachutes experiences air resistance. When the air coming out of the balloon is trying to push the balloon here and there, the same time the parachute is experiencing air resistance, which is stopping the balloon from moving. They find a balance, and this is why the balloon doesn't fly up so far, but the parachute doesn't come down in a straight line.